Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, June 15th. Brought to you by Vunabaka.com, a new surf and water residential community in the island of Fiji. First up, we'll take a look at significant wave heights for the North Pacific Ocean. We'll just put this in motion and roll through it. Basically, there's a little bit of wind swell off of Northern California generated by high pressure centered about here, causing a gradient along the coast. That results in north winds, results in wind swell. And there was some of that going on Sunday. But as we get into the week by about Wednesday or so, that starts fading out, and here we go. We're on late Wednesday and it's all but gone. Another low pressure is supposed to come off of Japan. The models originally showed 20-foot seas, but that is settled back to reality now and really nothing. Then after that, another little low up in the Gulf of Alaska, it looks like, but no seas from that. And then we're a week out, and basically it looks like a pretty calm pattern going on. Not even so much wind swell to look forward to for the Northern California coast, or for Hawaii for that matter either. So next we'll take a look at significant wave heights for the South Pacific. Notice actual seas south of New Zealand, 38-foot seas. This is a good sign, first in a little bit. Not ideal, not large, not necessarily traveling the right direction, but we'll take anything. So from here, let's go take a look at some of the other charts, get a sense of what's going on in the upper and mid levels of the atmosphere, and then we'll roll the wave height charts out here in a minute. So first up, take a look at jet stream level winds. These are up about 30,000 feet. These winds dictate the travel path of storms, and when they form in the right configuration, typically a trough here in the southern hemisphere pushing north, they help promote the development of low pressure down in lower levels of the atmosphere. Right now we have a patch of winds, what is that, about 110 knots. No real troughiness going here, but even regardless of that, there is low pressure south of New Zealand that's organized, that's trying to do something. Otherwise, the ridge is pushing down here. Well, so the Antarctic ice is about here at 65, and the jet, only in this little patch here is there even barely a little room to eke out gale development. Otherwise, the jet stream here is just pushing right over the Antarctic ice, and there's no hope for development. Put this into motion here. The better part of this is this trough that starts forming on Tuesday night, pushing well to the north. Here's New Zealand here. Not a whole lot of wind, maybe 100 knots, feeding up into the trough, but then it gets a little, it's forecast to get up to maybe 120 knots. This should help set up some sort of a circulation in the lower levels of the atmosphere. Now we're into Wednesday, and that goes on into Thursday. Then kind of pinches off, and notice most of the wind energy here starts pushing south rather than up this side, so that would force whatever system is developing here probably to start taking a southward dive. And sure enough, it starts falling south, but even another trough is forecast behind that on Friday. And then we kind of get that sort of settles out. We get a ridge going on here. That's probably going to cap off any storm development, but yet another ridge behind that on Sunday. So the good news in all this is from an upper level perspective, things are starting to look up finally for the South Pacific. It's been a pretty good long run here where we haven't had nary a drop of storm energy down there. So any sort of even a tease by the model is definitely welcome. So next we're going to take a look at surface level winds and surface pressure, and we're actually going back to Saturday night so we can see the start of this little gale here forming southwest of New Zealand. We'll put it in motion instantly, boom, 50, 55 knot winds by Sunday morning, and the ice line is right around in here somewhere, so it's on the hairy edge. But we'll roll that out. That storm by Monday morning, it's all but gone. So whatever swell generation is happening right now. Continue to put this out into motion. Rather weak pattern, something trying to organize here on Tuesday. But here comes the next low starting to form southwest of New Zealand. Put that into motion, and there we go. Nice little patch of 45, 50 knot winds. This is aimed up, definitely up the Great Circle Pass to Hawaii, just barely clear there of New Zealand, and for sure into Southern California. Probably pretty much shadowed by Tahiti, but maybe not too bad. Put this, oh, and Costa Rica, of course. Let's take a peek there. really cutting across the paths to Costa Rica. So this is really a Tahiti and a Hawaii prime target swell, with California and the U.S., getting the secondary energy. So that thing actually pushes north into Wednesday night, still 45-knot winds, then starts fading out. Another system develops under it, 45-knot winds, very small fetch area again, and doesn't hold together nearly as well. But that's basically three systems right in a row, and we're not even at the 150-hour mark. Things sort of settle down. Notice high pressure starting to build, push south here. Watch this. I'll put this back into motion. You can see it building here, falling south. And when it does that, it starts pushing the wind vectors, even on this system here, down to the south into Antarctica. So a little bit of a break there. Let's go check out the significant wave height chart now. So here we go, 18Z Sunday, the 38-foot seas that we talked about earlier. That system, as expected, pretty much fades out by Monday morning. So, well, actually, let's put it back. Let's go take a look. I mean, look at that. It's just basically a 12-hour system. Relative to Hawaii, the swell vector is pretty much cutting across the Great Circle Path. So, sideband swell at best for Hawaii. California, better direct energy, even if the winds are straight west, which they were. There's still some energy coming up into, but right through the Tahiti swell shadow relative to Southern California. What's that, about 208, 209 degrees in Northern California? Yeah, about 207 degrees, something like that. So it's shadowed, but still, anything is good. We'll take it. Costa Rica. There we go. Aims right up the paths to Costa Rica. It looks like about 210. So better angle there. Interesting note, we did a little study. If you had a system right here and you tried to guess how long would it take the swell to reach here versus here if it was, let's say, a 17-second period swell, and the answer is, you'd be amazed. The swell arrival times is give or take 6 or 8 hours, something like that. I mean, it's a really minor difference. So anyway, just a bit of a curious point there. The distance is very much the same between all locations. So here we go. We're into Tuesday night. Remnants, another system trying to get organized here, but basically it's almost east of the Southern California swell window. Not so much to worry about. But here comes the next system. Here we go. Wednesday 18Z, Wednesday night, 32, 4, 6, 8-foot seas. Let's take a look relative to Hawaii. Sure enough, just barely squeaking in there. Free and clear. California, definitely free and clear. And actually, it looks like it's clear of the Tahiti swell shadow. It's hard to make out here. It looks like about 216 degrees for Northern California and 218 for Southern California. So that's good news. Free and clear initially, and it continues pushing north and still in the clear zone. This is good news. Whatever little swell it makes, because it's a tiny fetch area, it'll all come hit up in this area, California, Hawaii, Tahiti, and again, not so much for Costa Rica from this one. So we put that into motion. That one fades out. Another little system right behind that, 32-foot seas, and again, that would be free and clear of the shadow, but it doesn't last very long. And then we're into just about the end of the run, and there you can see already the swell vector starting to head south. So that's kind of the end of that little run. But at this point in time, looks somewhat interesting. At least there's some hope and some potential energy in the pipeline. Good news for all locations in the Pacific. Next, let's take a look at long-term projections. What's going on with our potential El Nino that is supposedly developing in the equatorial Pacific? First up, Southern Oscillation Index. Currently 10.82, the daily number. The 30-day average, 10.23. Positive numbers here. This is suggestive of the inactive phase of the MJO, certainly not suggestive of El Nino. And then the 90-day average, 3.43, which is at least pretty close to neutral. But the SOI doesn't tell the whole story. You know, as we saw massive westerly wind bursts occurring in the far west Pacific in January, February, March, and even to a lesser extent into April, the SOI never really budged from neutral. So this is not necessarily an indicator of what's happening, but still something to monitor. We would want to see these numbers all turn negative and continue negative, not just a couple of days, but several months in a row if El Nino were in fact in play. And what we're really looking for is when these numbers go negative and stay negative, that suggests that El Nino is actually having an effect in the atmosphere, and that's really what we're looking for. But it's way early in the game right now, being it only mid-June. Next, let's take a look at surface level winds. Actually, these are the 850 millibar winds up about 4,500 feet. And these are wind anomalies, differences from normal for this time of year. Here's Australia, Philippines are out here. This is the West Pacific, dateline's right here. We have easterly anomalies. This is not what we want to see. We want to see westerly anomalies. And this is the first time we've seen any easterly anomaly at all this year, which is actually pretty remarkable in and of itself. I mean, it's westerly anomalies that push warm water to depth in and around the dateline and then create Kelvin waves, and the Kelvin waves is what, when they hit the Galapagos Island and Ecuador and Peru and start upwelling, that is what starts building warm water off the coast there, and that is what sets El Nino in motion. As of right now, these easterly anomalies started a couple of days ago. They're forecast to not go for too particularly long, but still, it's a little bit worrisome. There's some concern that if the easterlies start, you know, these are normal trades, a little bit stronger than normal. If they get too embedded and too entrenched, that could shut off the warm water pump and maybe put a cap on whatever El Nino is developing. But we're not there at this point in time. Okay, East Pacific, dateline again right here, Galapagos Island, basically neutral anomalies, except weak easterly anomalies here south of Hawaii. So not too bad at the moment. Next we go and take a look a week out. A week out, boom, nothing. Back to dead neutral. This is exactly what we want to see. There's even hints of westerly anomalies. They're too far to the north. I mean, you really want to see it within a couple of degrees either side of the equator, and particularly in the region bound right about here. Okay, from not even 120, but about 135, but really in more right in this region. So this is good news. Whatever easterly anomalies are occurring right now are forecast to die in less than a week. And we'll also go take a look at the East Pacific. Weak hangover easterly anomalies, but nothing significant here. Actually, the models are looking better than they have even a couple days ago. So this is good news. This easterly anomaly situation looks like it's going to be short-lived. Here's another view, same thing, but what this is over time. Here is the far West Pacific. Here is the far East Pacific bound here. This is time. We're looking May, June, current, and then here's the forecast. So notice all of May was basically just this muddled pattern, dead neutral effectively. And then in the East Pacific, starting about the 10th of June, we started, the blues are the easterly anomalies, reds are westerly anomalies. We started seeing these easterly anomalies develop, not so much a concern where they were in the East Pacific. When they start getting entrenched around the dateline, you start getting concerned. According to this chart, by 17th, 18th, we're pretty much to be through that. That's all of what, 3 days from now? We're talking Tuesday or Wednesday or so. If that's the case, no big deal. And you sort of look at the forecast here, and not, you know, nothing, no strong easterly anomalies forecast afterward. What's interesting is this wall of westerly anomalies. If that could just make its way into about here, we'd be in really good shape. Next, we take a look at the longer range models. These are go out 15 days, basically 2 weeks. The blues are the active phase of the MJO, westerly anomalies. The reds and yellows and oranges are the inactive phase, what we would consider easterly anomalies. And what you see per the CA model, which is a statistical model, is suggesting that the active phase of the MJO is in fact supposed to wake up, is supposed to make it to the dateline, and in fact we're supposed to start getting some sort of westerly anomalies, according to this model. If you go look at the GEFS, which is basically just the GFS model ensemble mode, it suggests that the active phase of the MJO is to hang here in the maritime continent. Look at this, 120 east. That's exactly where we saw that wall of westerly anomalies. So what we're really hoping is this model is right, but that the statistical model is a little more right, and it pushes the westerly anomalies clear into the West Pacific. The reality is it'll probably be somewhere between the two. We've been digging through all kinds of other models, long-range models, and we've seen some suggestions that in fact that westerly anomalies are in fact supposed to develop in around 150 east at some point here later in the month. So that would be good news if it were to happen. But again, making forecasts 2, 3, 4 weeks out is a little bit risky. The models sometimes have a hard time even getting 4 to 5 days out into the future, so that's a high risk bet. But just for fun, we'll take a look at the 40-day forecast. This is at the 200 millibar level, jet stream level. So here we are, let's say the 15th of June. The greens are the active phase of the MJO, and they show it actually holding together somewhat, making it the whole way into the East Pacific by about the 10th of July. But then they also show another inactive phase coming behind that, starting about the end of June, working its way across into almost the end of July, and then the next active phase forming behind that. The interesting thing is this model has steadily overhyped both the active and the inactive phases, and then when they materialize, they're basically just dead neutral, and you can hardly tell the difference between the two. Notice easterly anomalies are supposedly happening right now in the upper levels of the atmosphere. We're showing the active phase of the MJO. That is consistent with the thought that whatever easterly anomalies we have, they're going to be gone in a couple of days. So that's good news. Next, let's take a look at sea surface temperature anomalies. To date, 612, good warming occurring here. The signature triangle, Peru, Galapagos, up into Central America. Nice warm waters, all in about the 2-degree range. Plenty of data suggesting 3-degree water, and maybe even a couple little pockets, like maybe right there to almost 4 degrees. Seems hard to believe, but that's good. Historically speaking, this is not dramatic. This doesn't even touch the 97 El Nino, or for that matter, the 82, 83 El Nino, and But for this time of year, it's pretty good. And the issue is, so let's talk a minute. All this wind, all this warm water here was produced by Kelvin waves that were generated over here in January, February, March, and April. Takes 3 months for that to get here. This is all right on course. What the issue is there has been no more westerly wind bursts in this area. There has been nothing to seriously pump more reinforcing warm water into this pool since about the beginning of May. Okay, so we got what we call a 6-week hold from May to, we're in the middle of June now. So this is all a result of something that happened January, February, March, April. Okay, at some point the well's going to run dry. Trades pick these warm waters, start blowing them this way, okay? But the issue is there's nothing more lurking underneath to reinforce it, so at some point these temperatures are going to start cooling off. So the issue is we're very much looking for westerly wind bursts as soon as possible to start restarting the pump, get more warm water pulling into this area, because we need to continue to have warm water for at least 3 months to have some impact on the atmosphere. Once the atmosphere starts responding to the warm water, what it'll do is it'll actually create westerly anomalies and start the pump up itself. But you got to have enough. You really want to keep the pump primed. You don't want it shut off. You don't want easterly anomalies, and you don't want cold water to start clogging the pipe, so to speak. So as of right now, everything looks great in terms of what's going on. I mean, look at this warm water here, warm water here. There's piles of warm water. A little concern here is this cool pool developing here. This is a sympathetic cool pool to what we believe is the easterly anomalies that are currently happening here. It's not strong. It's not particularly threatening at this moment in time. Just something to watch. This can be an early warning sign, along with something else that we're going to talk about in a little bit here. Here's another look. this is sort of sad. This was a great chart. The scale, they got some sort of automated thing going on with the scale. It's completely hosed up the chart, so you really can't tell what's going on. But we're going to do a close inspection here. And here, I don't know if you can see it in the resolution on the video, but here is 4-degree plus anomalies, and this is actually increased in size. It was just a dot a week ago. Now it's clear, it's obvious, 4 degrees anomaly, and this, all this is 2.25 plus, so you can assume that it's at least 3 degrees over a good portion here. So this is actually fairly impressive. This is solid, especially given the time of year. We're in a great place. We just need some sign that more warm water is going to get pumped east in the near future. Here's another view. Now here this is interesting. So here's actually, you know, actual wind speeds, actual water temperatures. It's the anomalies that we're interested in. This shows 1 degree anomalies pretty much over the entire width from Ecuador over to the dateline and beyond, which is about right. It shows a little bit displaced to the south here. I'm not sure that's completely true. But what we're really looking at here is, notice this easterly anomalies. These are first time we've seen this all year. It started 2 days ago, and if it only lasts another 2 days, that's not a big deal, especially if it's followed up by westerly anomalies. But just something to be aware of. Next, take a look at subsurface temperature anomalies. So here's the date line this way. This is the maritime continent over here. Ecuador and the Galapagos would be over here. Notice, and these are actual temperatures. Notice a pretty flat thermocline, 20-degree thermocline line here. That's typical of El Nino. If you saw it go, you know, the thermocline going way up here and cold water was off here, that would be a bad sign. But here, take a look at the anomalies. Still, this consistent 5-degree pocket here, it hasn't budged for weeks. This is again the result of all the warm water that was transported from the West Pacific into the East Pacific, pooling up here. The pool looks good. The pipe is open, as you can see. There's still this consistent bleed of warm water coming through the open pipes. That's good news. But if we had another westerly wind burst, as we've said before, that would be even better. It would give us more confidence in the development of El Nino. And here's yet another view, same deal, different depiction, but basically says the same thing. Here's your 5-degree anomalies pulled up here, even 6 degrees according to, yeah, that is 6 degrees. But again, some of this is modeled data, some of it's real data. We'll go up here and take a look real quick. Oops, where are the sensor lines? There they are. Good news is there's a line of sensors strung down from a set of buoys right here, so they're getting hard data. That's the same data that's in about this area. So this is probably pretty close to reality. And then finally, the revised forecast from the CFS version 2, Nino 3.4 sea surface temperature anomaly forecast. It has degraded again, well, or pretty much it's holding now. At one point, it was predicting water temps up about 1.75 degrees when the westerly wind bursts and everything were going on back in the March, April time frame. It has settled back down to about the 1 to 1.1 degree time frame now, which is still El Nino, which is still decent. It's not a super strong one, but you know, that might be good too. What would be really good is if we could get a multi-year El Nino out of this thing, if it really kind of settled down and just muddled around in about the 3/4 degree and then sort of petered out this year and came back next year. That would be even better, to get a 2 or 3, and you can get this occasionally, get these 2 or 3 year-long pulses of near El Ninos, but that really gets the atmosphere going and sets momentum going over a multi-year pattern. Don't know if that's going to happen, just speculation as of right now. But so here's the latest data. So not wanting to be the guy that throws cold water on the party, but here is surface currents, the Pacific counter current. We track this. Here's actual current speeds, and notice it's going west to east. That's typical of El Nino, exactly what you want to see. It's a lot weaker than it was. There is this little hint of easterly anomalies, though, easterly actual current running through this. And what's even a little bit more troubling is there's actual easterly anomalies here right in about the core of the Nino 3.4 region. There's still the westerly component running above it though, so it's hard to say if this means anything yet. It's only been here for about I think June 2 was the first time it showed up, so it's been 5 days. We're waiting for the next update. It should post any day now to see if this is developed, whether this is just sort of a temporary thing, and we think it probably is at this point in time in association with the easterly wind anomalies that are occurring over the exact same region. If those easterly winds blow out, the current will settle down, but we still need westerly winds. That'll set the current and give it a little bit more strength and probably wipe out this anomaly part, and that will reprime the pump. So just something to be wary of. So that's our forecast for this week. In general, El Nino en route at this point in time. A few little bumps in the road to be wary of. Also, more short-term southern hemi swell. Looks like it's to be generated this week. Nothing huge, but at least something that will give us some rideable surf in California and Hawaii and most of the other locations as well. So something to distract us while we watch the long-term El Nino picture develop. And as always, many thanks to our friends at vunabaca.com, this new developing residential community in Fiji. Check it out, their website, vunabaca.com. Really an impressive project. Thanks again. We'll do this next week, same time, same channel. Thanks. Bye.